Hello there. In today's video we're going to be having a look at interpreting infrared spectra. Now, infrared spectra arise when molecules' bonds have radiation fired at them, and this infrared radiation causes a change in vibrational energy, and that's what we measure on our spectrum. It's a change in vibrational energy. It's the transmittance of that radiation through. Now, the first thing we should do whenever we see an infrared spectra is to put on some lines. The first one is at 1500, the second at 2000, and the third at 2500. Now, this is the first thing you should do whenever you see an infrared spectra. You shouldn't attempt to do anything else until you've put these lines on and labelled up your regions. This first region, from the beginning of the spectra to 1500 centimeters to the minus 1, is the carbon single bond region. Our next region along, from 1500 centimeters to the minus 1 to 2000 centimeters to the minus 1, is the carbon double bond region. Our third region, from 2000 to 2500, you've guessed it, it's the carbon triple bond region. And our final region, from 2500 to the end of the spectra, is the hydrogen single bond region. Now, let's have a think about some example bonds we could find in the carbon single bond region. We could find carbon single bond carbon, carbon single bond oxygen, and we could find carbon single bond to a halogen. Now, this area here, the carbon single bond region, is known as the fingerprint region. And the fingerprint region can be used to identify a substance, because the fingerprint region is characteristic to each molecule. However, when we are interpreting an infrared spectra in the exam, steer clear of the fingerprint region. It is not worth going there. It can get so incredibly complicated in an exam that there is absolutely no point wasting your time and throwing away marks looking at the fingerprint region. Concentrate on the functional groups that are present within the other three regions. Now, within the carbon double bond region, let's have a think about some different bonds that we could find here. We could have a carbon double bond carbon in an alkene. We could have a carbon double bond oxygen, a carbonyl group. So let's have a think about the carbon triple bond region. We could have carbon triple bond carbon in the alkyne functional group, or we could have carbon triple bond nitrogen in a nitrile. And let's have a think about the hydrogen single bond group, our last area. We could have hydrogen single bond oxygen. We could have hydrogen single bond nitrogen. We can also have hydrogen single bond carbon, but generally it's best to steer clear of hydrogen single bond carbon if you can avoid it. Now, there's always plenty to talk about on an infrared spectra, so don't worry that I'm saying to you ignore the fingerprint region, ignore hydrogen single bond carbon. There's always going to be plenty to talk about as well. So let's have a look at this spectra. Now, remember, we're going to need our data sheet to interpret spectra. The exam board don't expect you to remember the specific area where you would find a certain peak. That's in your data booklet. So let's have a look at this first peak here in the carbon double bond region. We're ignoring the fingerprint region. We're going to start here, and it's possible that in the exam they may label them up for you. They might not, but chances are if they want you to talk about, if they've labelled something up, then they want you to talk about it. So I'm saying this peak here occurs at 1700 centimeters to the minus 1, and that corresponds to, now then, 1700 centimeters to the minus 1, that corresponds to a carbon double bond oxygen of a carboxylic acid. So that's that part there of a carboxylic acid. And that's our first peak. Now, we've got nothing in the carbon triple bond region, but we do have this in the hydrogen single bond region. And this to me looks like it's sort of starting somewhere around 3000, maybe 3050, and ending pretty much on 2500. And if we have a look at our data sheet, we will be able to see that the OH stretch in a carboxylic acid occurs between 2500 and 3200, and it also says that the stretch is broad. So let's have a look at that one. 2500 to 3200 centimeters to the minus 1 would suggest the OH of a carboxylic acid. Now we're in the excellent position here because we have both parts of the functional group. So we can determine that whatever we have sampled here, the sample must be a carboxylic acid. And that is how we interpret infrared spectra. Now, it's worth having a think about why the peaks look different. Here we have one that's long across but not very long down. Here we have one that's very narrow but very, very sharp, very long down. The first peak to talk about is a strong peak. Indicates that the bond is polar. So let's have a think about some polar bonds. We could have carbon double bond oxygen as we had here in our example. That's going to be a delta positive on the carbon, delta negative on the oxygen. We could have a carbon single bond oxygen. Now that's going to appear in the fingerprint, so we won't look for that, but we need to be aware of things like that. In summary, strong peaks where the transmission is very low that come all the way down the spectra indicate bond polarity. And the second type of peak that we've got to talk about is a broad peak when the stretch is very wide. This is indicative of hydrogen bonding. So let's have a think about hydrogen bonding. That's when a highly electronegative element, such as nitrogen, oxygen or fluorine, coordinates a lone pair of electrons to a hydrogen atom covalently bonded to another highly electronegative element, namely nitrogen, oxygen or fluorine. So bonds that could undergo hydrogen bonding are our OH stretch, our NH stretch. Those are ones to look out for. If we have a strong peak, it's going to be a polar bond. If we have a broad peak, the chances are it's a hydrogen bond. And that's about it for interpreting infrared spectra. So remember, the first thing is to put on your lines 1500, 2000 and 2500. Separate your spectra out. Ignore the fingerprint region. Look to see what we have in the double bond region, what we've got in the triple bond region, and what we've got in the hydrogen single bond region. Are those peaks strong or are those peaks broad? If they are, tell your examiner, let them know that you know that they are a strong peak or a broad peak. Use the technical language. And then be able to determine, based upon the area where the peak is, using your data sheet, what that might signify, and then make a deduction about your molecule. That's everything. I hope you found this tutorial informative and helpful, and so if you have, don't forget to give it a share with other people. Thank you very much.